question 10, we have a particle of mass m connected by means of a light inextensible string of length L. That's what they're showing us here. We'll do a bigger diagram. We've got an L. With H, we have mg, mass is m, and fixed point O up the top. So we're not given the radius. It says draw a clear diagram. This is not too clear, but if we want to add in the circular part, something like that, we have the center. So we can get this one straight away. It's going to be the square root of L squared minus H squared to complete our diagram. And now let's look at our forces. We're asked to show that H is equal to this guy here. That's W squared, so it's angular velocity. So let's have a look at what's going on here. In terms of T, we have a cos, let me put our angle in, the cos of A is equal to the square root of L squared minus H squared. A over H, which is L. In terms of T cos A, it's going to be just times T. T sine A, so we get sine A and just put T beside it. Sine A is going to be H over L. So T times H over L is sine T sine A. That's my force going in that direction. My force going in that direction. Down in this direction is mg. And is it on a table? It's not on a table, so we've no reaction force here. So we can say that mg going down is equal to th over L going up, T times H over L. So Lmg divided by H is tension. And if we get the centripetal force, we're looking at W here. So we have the square root of L squared minus H squared times T over L. My force going in this direction is equal to M, which is just M, W squared or, and the radius is also the square root of that guy, so I'll change it to that so I don't have to write it out again, or is the square root of L squared minus H squared, so thankfully these cancel. It was looking a bit awkward. So T over L is equal to M W squared. Looking for the W, so T divided by L times M is equal to W squared. So we can say that the T is this LMG over H. So LMG over H divided by LM over 1, which so we'd multiply by 1 over LM, is going to be equal to W squared. And the L's and the M's will cancel, leaving G over H is equal to W squared. So we're actually asked to show H is equal to, so H and W squared swap place, so H is equal to G over W squared, which is what they were looking for. And then if the circle must remain at least 0.25 meters below O, so H has to be greater than or equal to a quarter, 0.25, H has to be greater than or equal to a quarter. Find the max value of W. Okay. Right, and if H has to be greater than or equal to 1 over 4. We have H as this, in terms of G and W, is G over W squared. So we can say G over W squared has to be greater than or equal to a quarter. Let's multiply this by 4 to get 4G over W squared has to be greater than or equal to 1. So for this whole thing to be greater than or equal to 1, the top needs to be greater than the bottom. Or W squared would have to be less than the top. W squared would have to be less than or equal to 4G. So once the bottom is bigger than the top, it'll be, sorry, the bottom is smaller than the top. Bottom has to be smaller than the top for it to be greater than 1. If you imagine 2 over 3 is not greater than 1, but 3 over 2 is. So 4g, w squared has to be less than or equal to 4 times 9.8. W squared less than or equal to 39.2. So the max value will be when it's equal to 39.2, so W will be equal to the square root of 39.2 for its max value. So W will be equal to square root of 4g to 6.26 radians every second.